This week we'll learn how to remove chart junk and clean up our matplotlib plots for your next presentation. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for Unidata. This week we're going to talk about how to clean up your plots and remove some of what Edward Tufte calls chart junk. Really, the idea here is we want to reduce the amount of ink on the page to the minimum possible so that whoever's looking at your chart can actually see the data and try to pull that information out and see what you're trying to show them. And that's harder to do if there's more unnecessary things on the page to distract them. So we're going to make some fake temperature data, then we're going to plot it in a normal way, and then we're going to remove some of the chart junk. I think you'll see that with a few lines of Python, you can make your charts a lot nicer to look at. Now, I'm not going to say you're going to use this for every publication plot that you make, but I've seen many slide presentations at conferences that could benefit from these few lines of code. All right, so let's get started. Going to import matplotlib.pyplot as plt, import numpy as mp, import pandas as pd, and of course use our matplotlib inline magic since we're in the notebook. So the first thing that I need, since I'm going to create a temperature time series, are some times. And that's why I brought pandas in. This is a little bit of a heavyweight way to do it, but I really like the date range function in pandas. So I'm going to create a variable called times. It is created with pd date range. And the reason I like it is for this very simple syntax. So I can use today's date. Then I can set the end date. Maybe we'll make it 5 days from now. And then I can set an interval, which is called freak, at 1 hour. And now if we look at times, you see that starting at 0z on today the 5th, up to and including 0z on the 10th, we have a date range. And it is length 121. Now the way I'm going to create the fake temperature data is maybe not the most creative out there. It's going to be a sine wave with some random noise imposed on it and an offset, but I'm going to go ahead and add a phase lag too so we can simulate a station that is, say, further west of another station. All right, so my temperature 1 time series is going to be numpy.sine 1 divided by 24 times 2 times pi. Of course, there are lots of ways that you could do this, but this is the quick, dirty way. We've got 121 elements. Now we're going to add our random noise and offset using mp.random.random, pass a tuple for the size of 121 elements. I'm going to multiply that by 0.5 to scale my noise down just a little bit. And finally add an offset of 25. I'm going to copy and paste that line for my second temperature, but out here I'm going to add a little bit of a phase shift, and I'm going to decrease the offset to 24. So let's take a look at what a very quick plot would look like with defaults. Okay, so this isn't too bad. Matplotlib puts a lot of effort into making your plot look pretty good with very little code. We've got some nice colors. The lines are different colors. We've got tick labels that were intelligently chosen to be 1 day. The font size might be a little small. But think about what you're trying to show here and what pieces of this chart we could remove. So pause the video and figure out what pieces you might remove or add. All right, so looking at the chart, well, for one, I'd probably make it a little bit bigger. I would label the 2 lines. That's something I would add because right now I don't know what those lines are. And maybe these spines on the outside and the actual tick marks might not be that useful, but a grid would be useful. So let's try making some of these changes. First of all, I'm going to use the more object-oriented approach for most of this, just for its versatility. I'm going to set the fig size, in this case, to be 10 by 7.5. Now, your figures generally look best when they're about 1.33 times wider than they are tall, unless, of course, you've got a lot of subplots or something else going on. Okay, so now I'm going to call ax.spines top. I'm going to say .set visible is false. So that's going to set this top spine to not be visible. And of course, there are a couple ways you can do things like this. This is my preferred way, and in fact, I have a template set up for myself to do this when I'm making plots, because then I can easily comment one line out and see how it would look with maybe I want a bottom spine, or maybe I want a right spine. So I'm going to turn all 4 spines off. All right, so what about the ticks? Well, we want to make sure that we only get ticks on the bottom and the left. We don't need top and right ticks necessarily. And this could be set by your RC Params file. So we'll just make sure that they're off. Okay, now we can set the tick font size. Here I do use the PLT version of the call just because it is a lot easier to remember. So I'm going to set the font size to be 14. Font size to be 14. I'm going to turn the grid on. I'm going to use a line style of a dashed line. I'm going to set an alpha of 0.5. I'm going to go ahead and plot my data. So times T1 times T2. And let's grab a handle, you'll see why here in a little bit, to line 1. And remember the comma, we're just throwing away, we're unpacking and throwing away everything else. Line 2. I'm going to set the X limit, and if you comment this line out, you'll see why. It's because the X limits will not be set to something that makes sense. So I'm just going to set them to the first and the last element in the times list. And we're almost done. Tick params. This is where I think you can really dress up the plot. You can determine where tick labels are, or tick lengths, or if the ticks are there at all. I played around with some of the parameters, and I determined that on both axes, for both major and minor ticks, which is what the which argument means, the bottom I don't want, the top I don't want. I do want to label the bottom though. I don't want left ticks or right ticks, but I do want to label the left. We'll go ahead and line wrap that. And let's make our plot. Well, to me, this already looks quite a bit better. We don't have all of this dark, heavy lineage around the outside of the plot. We've got some guidelines to guide our viewer's eye for the dates and the temperatures. But the thing that's still missing to me is which station is which. We can tell that the orange station's probably further west, but we don't know what the stations are. So the way that I prefer to label them, and the reason that I went ahead and got these handles to the lines here, is I'm going to use a text. I'm going to position the X text at the last time element. I'm going to position the Y at the last temperature element, so our last data point in the series. Then I'm going to specify the label, so KTUL. Now here is why I saved that handle. I can use L1.getColor to color the text the same as the line, and now if I add more plots above or below, it doesn't matter, it's always going to have the same color as the line for the text. And for the font size, I'm going to choose 16. Now we can use this same line again, and if you were doing many of these, of course you would write it in a loop, but you would probably have a dictionary or some other construct that's holding all of your data. So I'm going to make this station Denver, and it is the color of L2. So now at the end of the lines, we've got the station identifier, the same color, at the value of the last data point. So I think that you'll agree that on a slide for a conference talk or on a poster, this has a lot less chart junk on it. It's a lot easier to read. Again, you may not want to use it in your publications. In fact, in publication plots, I like larger tick marks on all axes so that somebody can use a ruler on the print copy of the paper and try to determine some of your data points. But for a presentation, this is perfect. It's going to project very well. I hope that you found this useful, and I'll see you on next week's MetPy Monday.